right, welcome back to 5.2 lesson on evaluating and graphing polynomials. This is the graphing part of the lesson where basically what we want to do is just to describe the in behavior of the graph. If I give you a polynomial, you should be able to tell me what the ends, more air quotes, the ends are doing on that graph. Take a look at Disco Stew there from The Simpsons, and he's describing one type of end behavior. You'll see what that means in just a little bit. Okay, so we're going to start this off with an activity. I would like for you to print off a worksheet, a handout off of my website. Okay, so let's assume that you have navigated your way successfully. You have come to my webpage, and we're under the main page for Unit 6, and right underneath it we're going to 5.2, evaluating and graphing polynomial functions. Okay, so lesson notes, etc., etc. Let's look at the in behavior handout. So that first PDF file, you want to click that and print that out. It is two-sided, so if you wanted to do it on both sides, you might save yourself a piece of paper. Right down below it, if you have the Sketchpad Explorer app on an iPad, then you can open that up and follow along the investigations with me. It should be a lot of fun. Alright, so I'm going to assume that you already have that handout. So what we're trying to do is we're investigating on Geometry Sketchpad what exactly are the ends doing. And what do I mean by ends? Look over here at this flipping math logo. You see where the arrows are pointing? That's what we're talking about. Where are those things pointing for different kinds of polynomial functions? Okay. So here's a little bit of terminology for you. So in behavior refers to what a graph looks like as x approaches infinity, either positive infinity or negative infinity. And this is the way that I write it. Take a look in blue as x, and then it has a little arrow, and then positive infinity. As x approaches positive infinity. What's y doing? What's f of x doing? Is it also going to positive infinity, or is it going to negative infinity? Is it getting real big or real small? In red there, as x approaches negative infinity, looks like x arrow negative infinity. So we're talking about going on the graph, going towards the left in the x direction. As x goes further and further to the left, what's happening to your y values, your function values? Are they going down or are they going up? Okay, so let's go ahead and take a look at Geometry Sketchpad activity, and then we'll try to put all that knowledge together and make some sort of conjecture about it. Okay? Alright, so in the first page of this sketch, we have ourselves a linear function, y equals ax plus b. It's like mx plus b. And we have two parameters here. We've got an a, that's like the slope, right? And the b, which we know to be the y-intercept. So I can move my a, right? And I can move my b. The question is, my question to you is, which one of those affects where the ends, where the arrows are for this equation? Is it the a or is it the b? And then also, you're looking at this f of x and this f of x of 5, well, f of 5, and this f of negative 5 there, and looking at both of those numbers here, positive and here's negative. Okay. All right, now let's look at the quadratic one. So we have our quadratic in standard form, ax squared plus bx plus c. So this time we have three parameters. We have our a. All right, so move that a little bit. And my b, move that one. We're trying to pay attention to where the ends are, where are the arrows, and then the c. Which one of those is the only one that changes where those ends are pointing? Let's look at another one. Here's a cubic one. Cubic one, let's move the a. Wow, oh, that was really kind of cool. All right, so there's that business. Look at the b. Does it change where the ends are? We'll see, that's still, when I remove it up, it's still pointing downwards though. That one's still pointing up. Okay, how about the c? still staying the same. How about the D? Scooching it up and down. Which one was the only one that was changing where the ends were, whether they were pointing upwards or downwards? How about one last one? This should really hit it home, I think. All right, so we have our A value and our B value. Is that changing where the ends are? How about the C value? It's like this a melting wax or something. Is that changing where the ends are? No. Oh, how about the E? No, it's just moving it up and down. Okay. The only one in every single one of these examples that was changing where the ends were, as in if they were pointing this way or this way, like that, was the A value, the leading coefficient. That's the only one that mattered. Okay. Okay, so I've changed sketches here. Take a look at this one. This one takes away all of the parameters except A, just the leading coefficient for the linear, the quadratic, the cubic, and the quartic. And then these are the ones that I want you to use to help us fill out the answers in our worksheet. So you can see right down below that little box, I've got a little box, we'll fill out the little answers here. So we're looking at just the linear function. We know it's just the A value that affects where the ends of the graph are. Okay, so over here I got it positive, and over here I have it negative. Positive and then negative. Okay, so when it's positive, when my A value is positive, it's like I've got a positive slope here. As x gets bigger and bigger and bigger, look right down below in green, as x gets bigger, f of x is getting bigger. As x is going to positive infinity, f of x is going to positive infinity. So there's the first answer right down here in blue. Okay, now let's see if x is going to the left, if it's going to negative infinity, look at f of x. It's also going to negative infinity, right? So there's the answer, the second answer. This one's right here in red. It's going to negative infinity. That's if my linear equation has a positive A value, or positive leading coefficient. Okay, let's make this sucker negative. Okay, so now it's negative. As x approaches positive infinity, look at the green dot there. You can see it's going down, right? It's f of x is going to negative infinity. So there's the third answer right there. It's going to negative infinity. And let me make x smaller. See the dot, green dot? So zooming back over there. As x is going to the left, f of x is going upwards. It's going upwards. It's going to positive infinity. So there's your first set of answers for the linear one, which is an odd degreed equation, right? X to the first. Let's take a look at the quadratic one. Quadratic, again, we're just looking at the leading coefficient, the A value. Here it's positive, and here it's negative. So those are the two possibilities, whether it's positive or if it's negative. Let's make it positive first. Okay, so looking at the table, as x approaches positive infinity, move this off to the right. As x is getting bigger and bigger and bigger, look at f of x. It's getting way bigger. It's going to positive infinity. Bam! Okay, as x is getting smaller and smaller, watch for a green dot zoom through here. It's going to come up here. There it goes. Oh, look, this is also going up to positive infinity. As x approaches negative infinity, f of x is going to positive infinity. So both ends are going upwards. Both ends are going upwards. Okay, let me zoom it back over here. And let's make our A value a negative number, like so. Okay, as x goes further to the right, positive infinity, now our function values are going downwards, negative infinity. So there's the answer on that one. Okay, now let's make x go towards negative infinity. Oh, it's going up, and back down. So now f of x is also going to negative infinity. Both ends are pointing downwards, and this is the way that we write it, as f of x. As x is approaching negative infinity, f of x is approaching negative infinity. Okay, that was an even degreed function. Let's look at another odd one. Let's look at the cubic one. So the cubic one, we're just looking at the a value again. It's positive over here. Leading coefficient is negative. You can see it just switches directions based on it being positive versus negative. So let's make it positive, something right in here. As x approaches positive infinity, going further to the right, look how big f of x is getting. Real big. Going to positive infinity. Here's the first answer. And as x goes towards the left, we should see a green dot come right in there. It goes down to negative infinity. Those answers look vaguely familiar. Okay, let me zoom it back over here. Let's make our a value now a negative number, whatever we want. Okay, as x goes to positive infinity, this just keeps going down. Look at that, negative 47,000. Look at that, wow. Okay, so it's going to negative infinity. As this gets closer and closer, here comes the dot, here comes the green dot, burn. And now, as x goes further to the left, f of x is going up. It's going to positive infinity. Here's the next answer. Those do look familiar. Huh. Okay, let's do the quartic one.
Maybe you're seeing a pattern here. Maybe you're seeing some sort of a pattern. Okay, a value, if it's positive, it's over here, negative over here. Those are the two versions of the graph. Looks very similar to the quadratic one, right? Both of my ends are pointing upwards. As x approaches positive infinity, f of x is getting super big. It's also going to, oh, look at that, it's in the millions now. It's going to positive infinity. As x goes to negative infinity, then this green dot went back upwards again. It's also going to positive infinity. Both ends are pointing up. Okay, so let's do the negative side. On the negative side is f of x goes to positive infinity. This is getting real small. Negative infinity, you can see this. And then if x goes towards negative infinity, f of x is also going to negative infinity. Both ends are pointing downwards. Easy. So if you haven't seen the pattern yet, one more. Let's do the quintic one. Fifth power. It's another odd one. Which other ones were odd? We had the linear one, we had the cubic one. A is positive here, negative over here. Boop. Okay, so as x goes further to the right, f of x, look at that, to the 8th power, 10 to the 9th power, in the billions now, it's going to positive infinity. What about if x goes to negative infinity? Whoa, did you see that green dot? Barely. It's going down to negative infinity. All right, one more here. Let's just make it negative. Let's hurry this up. Okay, so as x goes to positive infinity, f of x going down. It's going to negative infinity. As x is going to the left to negative infinity, f of x is, no, it's going up. It's going to positive infinity.
The end. Okay, so let's go back to the slideshow. Let's put it all together. Put it all together and summarize it for even and odd functions. Okay, so this slide should pretty much sum this up, and this is at the bottom of your little handout there. We have a couple of different functions that are even ones, so the power was 2 or the power was 4. And then we have a couple that were odd, had 1, 3, and 5. So if we put those together, we could generalize this for even powers and for odd powers. So let's look at even ones first. I am going to relate an even power to something that you already know. Even power is like our parabola. Oops. Our parabola. Okay, try that again. We have a parabola like that, or we have a parabola like this. So the first one, the one on the left, the beard there is when a is a positive number. That's what we see over here. So from that graph, we can see that as x goes to the left, if it goes to positive infinity, f of x is also going to positive infinity. It's also going up. So I'm going to put positive infinity there. And as x goes further and further to the left, f of x is going, or the y values are also going up. They're both going to positive infinity. Okay, so this is another way of saying beard. Right? Okay. Now, when it's negative, that's the picture over here on the right-hand side. Negative, that's the mustache one. As x goes further towards the right, as it gets bigger and bigger and bigger, our function's actually going down to negative infinity. Same thing happens when x is going to the left, going to negative infinity. Our graph is also going down. Fancy way of saying this one is a mustache. I'm just going to put an M. I don't have enough room. I'll probably misspell it anyway. Okay, So for an odd one, the easiest one to think about is a line like this. All right, so we have a line like that, like it has positive slope, and a line like this as if it has a negative slope. So if you can relate it to these two cases, this is going to be a piece of cake. Okay, so on the first part, when a is positive, it's like I have the linear one with a positive slope. As f of x, or no, as x goes further to right, goes positive infinity, our graph is going upwards to positive infinity. And just the opposite is true. If x goes further to the left, f of x going down, negative infinity. And these two things get flipped around over here. The first part is x approaches positive infinity, our graph is going down, negative infinity. And going towards the left, it's going up, positive infinity. Not too bad. So knowing those kinds of pieces of information can help us figure out what our graph is going to look like. And whenever we start graphing it, that's one of the first things that we're going to consider. Okay, so I want you to now relate this to even and odd like this. So even in behavior is like a referee, where you got yourself a touchdown or whatever it is. Touchdown, and that's even. And it's positive like this, and it's negative when they're down. Okay, an odd in behavior, we're going to think of a disco dancer, because, disco dancers are pretty odd, right? So as you can see, that little guy right there, this is a positive in behavior, where they're going in opposite directions, and then negative, just flip those things around. Even, referee, odd, disco dancer. It'll be pretty easy to remember like that. All right? Okay, so on exercise 5, describe the degree and the leading coefficient of the polynomial whose graph is shown. So we're not asking for what the equation is. We just want to know what the highest power is, and if it is, not what the highest power is, but if it's like an even or odd, and if its leading coefficient's a positive or a negative. Okay, so since we have a disco dancer here, disco dancer, disco dancer. What does that mean? If I have a disco dancer, it means that I have an odd function. So it's odd. My degree is odd. Okay, does this thing, if I picture this as a line, does it have a positive slope or a negative slope? Well, this one is, as x is going to positive infinity, f of x is going to negative infinity, and that's negative. So my a value is less than 0. It's negative. Not too bad, right? That's pretty easy. Okay, so I'm going to give you an opportunity to try that on these two. So I just give you the equation. I want you to describe the in behavior like we did in the little worksheet. So you would write something like as x approaches positive infinity, then f of x is approaching something. So try that for those two. Give her a pause and come back. Alright, I decided there wasn't enough room to work here, enough space, so I put the answers right over here. So on the first one there, my exponent, my highest degree, 26, that's even. That means it's a referee, and it's going upwards because it's positive. So I drew myself a little thumb sketch there. I don't care what's going on with the little humpy things right in the middle. I only care about the ends. And so as x goes to positive infinity, this one's going up to positive infinity. As x goes to negative infinity, this one's going also up to positive infinity. Okay? And then on the second part of this, my degree is an odd number, 37. It doesn't matter what all the other stuff is. It doesn't even matter. Just that 37, it's odd, it's a disco dancer, and it's negative, so it's going to have like a line with a negative slope, starting up and going downhill. So I drew my little sketch. Again, I don't care about the little hump things. I just care about those two ends. As x goes to positive infinity, f of x is going to negative infinity. It's going down. As x is going to negative infinity towards the left, our graph is going up to positive infinity. Okay, one last thing to do. if f of x is represented by the graph below, looks like a parabola to me, x squared, okay, then if g of x is equal to negative x times f of x, what? Then describe the end behavior of this graph. Let me call up this pen. I'm going to have to write stuff through this. So if this is f of x, wait a minute, my pen's upside down. Okay, if this is f of x and it's a parabola, I can say that it is some variation of x squared. I don't really care about what the leading coefficient is, other than I know right now that a is a positive number, right? Because it's a beard. Okay, so we'll just say that it's some form of f of x. Now, g of x is negative x times f of x. Okay, so let me just stick that right in there. So that's negative x times x squared. Just a minute. And then that's negative x cubed. Negative x cubed. All right, so it's odd, which is a disco dancer. And it's negative. So let's just draw ourselves a little sketch for this, and it should look something like going downhill, like so. Something like that. And now my end behavior, as x approaches positive infinity, my graph is going down. F of x is going to negative infinity. As x approaches negative infinity, it's going to the left, our graph's going up to positive infinity. Ta-da! There we go. So that about wraps it up for today. Evaluating objective 1, evaluating polynomial functions. We did it by direct substitution and synthetic substitution, where the remainder was the same thing as if we would plug the x value into the equation. And then number 2, to describe the end behavior of the graphs of these polynomials, take a look at John Travolta right there. He's odd. His polynomial would be to an odd power, like third, fifth, seventh, so on. And so let's see, he's starting up and going down, and he'd be negative. Crazy. Okay, so here's your assignment. Hey, Rowan, do you have a question to ask me?
Yeah.
What do you want to ask me? Rowan? Is it something about your... Is it something about your end behavior? Is it odd?
Yeah.
Okay.